Today, we are going to prove trig identities. So instead of me just giving you an expression, I'm going to give you an entire identity. So it has an equal sign. This equals this. And we are going to show that those two sides are indeed equal, which means we'll know when we are done. Okay? The whole point is that when we get one side the same as the other side, we have proven our identity. Okay. So I can already see the excitement in some of your eyes that, we have an ending. All right. Now, here are the different ways we can do it. Okay. And like I said about 5 minutes ago, there are going to be a multitude of correct answers. Okay. Your answer is all of your work. All right, and there's going to be many different ways we can do this. So one way is to just work with the left side and use our identities in algebra until it looks like the right side. Or we can take just the right side and use our identities and algebra until it looks like the left side. Or, what's my or? No, it's all up to you. You could manipulate both sides at the same time until they're the same. Okay? Point of the matter is, when both sides look the same, you have finished your proof. Okay? Some of us will work with the right side, some of us will work with the left side, some of us will work with both sides. And depending on the problem, one way may be easier than the other. Okay, so there's no like one clear-cut path to do this. Okay, are there going to be ways that are easier than the other? Yeah, but if you get there, it doesn't matter if you took 5 steps versus 10 steps. Okay, as long as we can get there, that's what's going to matter. Okay, now when I say manipulate, I do mean use algebra and the 8 fundamental identities, okay? Which is what we practice in our homework this weekend. Okay. Now, I do want to make a note. We are not solving an equation. We are proving identities. So it is not allowed to move terms across the equal sign. You have to keep things on one side or the other, like they cannot move. If something is on the right side, it stays on the right side. Okay, you have to figure out the way to use algebra or identities to make two sides look the same without moving anything across. You basically have two expressions that you want to equal each other. Okay, it's not an equation that we're solving. We want two expressions to look the same. Okay. So what I'm going to do is on the whiteboard up here, I am going to write down our identities. Okay, did any of you create a note card with these on them as you did your homework? Okay, I can't remember if I thought of that suggestion before your class or not. As you're going through this, now you're eventually going to need to know these, but if you are feeling uncomfortable with these identities, if you need to write them down on a note card to have them to reference, okay, that might be a helpful way to get through these first few days of these proofs. Okay. All right. So I'm writing these on the board so we can reference. I'm going to give you some suggestions and some strategies on ways that can help you get through these proofs. Okay? So sine squared plus cosine squared equals 1. Tangent squared equals secant squared. Okay, so strategies that are helpful. First of all, and you don't have to write these down necessarily, let's just listen to them, and anything you want to jot down, that's fine. But be prepared to think, okay? These are kind of like puzzles. You were already exposed to the simplifying expressions on Friday. An algebra problem, a lot of you can look at and know right away what to do. These problems you're going to have to digest a little bit and come up with a plan. You may try things, it doesn't work, you have to go back. It's really going to push your brain, okay? But going into that, knowing it, just be prepared, okay? Sometimes, if you're not sure where to start, I might suggest starting with the more complicated side. It's a lot easier to take something long and drawn out and squish it together, okay, than try to take something and expand it out. Along those same lines, if there is a side with addition or subtraction, sometimes it's easier to start there, make common denominators, add or subtract things together, as opposed to trying to take multiplication or division and pull that apart, okay? So anytime there's like addition, subtraction, especially with some of these, like if there's fractions, make common denominators, add those together. That's a good place to start, okay? Look for opportunities to make substitutions, okay? That's why I suggest maybe for these first few assignments, having a note card or having your notes out with these on it so you can really visualize what you're looking for, okay? But look for those opportunities to make any of these substitutions that we wrote up here, okay? Try to factor. I did not realize that I had all of that on here. Try to factor. If there's an opportunity to factor, you know, that's always a possibility. Careful though, because you wouldn't want to factor like 1 minus cosine squared. You want to substitute that with sine squared, okay? So don't go crazy with the factoring, but it is a possibility. Biggest factoring you're going to see is like a greatest common factor we need to factor out, okay? Combined fractions, you know, if there's two fractions added or subtracted, add them together, common denominators, okay? Break up fractions. We saw something in one of our examples on Friday, right? If we have 1 plus sine of x over cosine of x, we can break that up into two fractions that are being added together and then use some identities from there. Okay. Multiply by the conjugate. We saw that in the example 1 over 1 minus sine of x. Okay, you remember that from Friday? We multiplied numerator and denominator by the conjugate to create a Pythagorean identity, so we could use that substitution. Okay. And then lastly, don't give up. There will be problems where you do a few steps and it's not working, and so you have to erase it and try something else, and that is okay. All right? Persistence is the key. Know that you're not going to have all of the answers right away. If you have 4 problems to do and you're stuck on one, go to a different one, come back to it. Okay? The more you do of these, the more comfortable you will feel and the more vision you will have. But you can't give up the minute or the second that it gets difficult. Okay? Erase, try something else. Okay? What we're going to do is we're going to do one example together, and then in partners, I'm going to give you an activity to do which will probably be after lunch. Okay, so write this down. This is the one that you saw at the beginning of our notes. Okay. Now, I also am going to have you write reasons or explanations next to each step, okay? That way I can follow your work, all right? So if you make a substitution using the Pythagorean identity, you'll write Pythagorean identity. If you factored out a common denominator, you'll say factored, okay? And I'll show you what I mean. Now, does anybody have a preference as to which side we start with, right or left? Charlene? Okay. Should we? No.
Well, what I would do is I would go on both sides and I'd split the tangent and cotangent and secant and cosecant into like the sine and cosine that are like the fractions using Pythagorean identities.
Okay, good. So we have some suggestions, okay? Now, do you remember me saying all of us are going to do these problems differently? Okay? So what I'm going to do is I'm going to take your suggestions, but I'm also going to like lead it in the path that I want it to go. Okay? So this is what I'm going to do. We're just going to start with one side. Tangent and cotangent are being added together. We also know that these can be written as fractions, right? Okay. So we can say that tangent is sine of x over cosine of x. Oops. Cotangent is cosine of x over sine of x. And we use the quotient identities to rewrite that left side. You're going to explain to me what happened. Okay. No, this is fine. And Darby, I'm going to hold off on the right side until we get a little bit closer to the end. Okay? Now, if we're going to add these two together, what would we need? Common denominators. So we are going to take sine of x over cosine of x and multiply it by sine of x over sine of x. And then we're going to take cosine over sine and multiply it by cosine of x over cosine of x. Okay, and what did we do there? We made common denominator, so that's what you can write. Common that says denominators. Okay? I think it's important for you to really break these up step by step by step. You want to be careful not to do too many things at once. Okay? So now that we have common denominators, we can add these two fractions together. So what we have is sine squared x plus cosine squared x over our common denominator, sine x cosine x. Okay, what did we do there? We combined our fractions. Okay. Anybody see an opportunity for substitution?
We can use the numerator is 1.
Okay. And what identity tells us that? What's it called? Pythagorean identity. I mean, if you are PYTH, comma, or period, identity, I'm gonna know what you mean. Okay? All right, some of us have a vision. We can see what's gonna happen here, right? Okay, what should we do with this fraction? Well, I would be careful. What I would do first, Jackson.
Could you break it up into two?
Yeah, you want to break it up into two before you start using those. Okay. So what I would do is I would write 1 over sine of x times 1 over cosine of x. Okay. Then we can say, what is 1 over sine of x? Cosecant x. 1 over sine of x is secant of x. Okay, is that the exact same thing we have on the right side? Is it? Okay. You want it to be the exact same thing. So what we can do, first of all, on the left side, we use our reciprocal identities. And then on the right side, we went ahead and used the commutative property to rearrange those. Cosecant secant is not the same as secant cosecant. Like, they literally need to look identical right and left side. I know that's picky, but that is the rule. Right and left side have to be the same. So do you see how we changed the left side and then at the end we changed both sides? That's fine. Okay? What we're going to do is after lunch, I'm going to give you 3 problems with steps for you and your partner to arrange in the correct steps and write down the reasonings with. Okay? So, I will see you soon. Okay, so with the activity that you just completed, between the two of you, there are 3 problems. So each of you needs to keep 1, and then you can fight over who gets the 3rd one. Okay? When you do your homework tonight, you have 1, 2, 3, 4, 5, 6 problems, 4 of which are required. Okay? You need to attempt all of those problems. Okay? There is no reason for you to, you can't just say, oh, I don't know how to do it. You have to at least try something, otherwise I'm not going to help you tomorrow. If you don't have a first step, I'm not going to go through that problem for you. I'm not going to do the work for you. You need to try something. Okay? If it doesn't work, that's okay. But you have to try something. Okay? Make sure you clearly write the steps off to the side. Okay, remember, you can change one side or the other or both at the same time. It does not matter. Okay? We have about 3 minutes left in class. Please make sure there are no scraps on the floor or on your table. And make sure my scissors and glue sticks get put back up here properly.